Okay, so welcome everyone, and good evening and good morning as per your time zone. Welcome to this workshop on cloud database performance. My name is Roshan. I'll be the instructor for this workshop. And just to give you background, I have 16 years of experience. I am with Isha from last 4 years. I take up SRE course, Cloud Performance Engineering course with Isha. And we are meeting here for the workshop. Uh, I started my career as a Java developer and then I moved into DevOps and SRE. I'm currently working as a principal SRE with one of the reputed retail giant. Okay, so that's brief. So what we're gonna do? So let me put the agenda for this session today. First thing. So what we're gonna do? We're gonna start. So we need to this workshop is for the cloud database performance. So we need to understand first, most of you would have worked on some databases on-prem or in cloud. So we'll understand in cloud how we should take up the performance and what are the factors from the infrastructure perspective, from the cloud perspective. Uh, we all know about the SQL tuning, right? About those things, database SQL tuning. So that's not the agenda for today. To understand the SQL tuning, that is same. Either you work on the cloud or you work on the on-prem. That's not the agenda. On the database performance, on the infrastructure side, how we operate in the cloud for the databases. So first of all, we'll understand the options available. So what are the difference? So first of all, we'll understand the difference between on-prem databases, and versus cloud databases. So we'll understand this first, right? That's going to be our first agenda to understand. And once we understand that, we need to understand how they are different, right? And then we'll talk about in the cloud, what are the database options we get. So we will talk about AWS here today. So AWS DB options. What are the options that we have? And what are different kinds of databases we have? So different kinds of databases that we have in AWS, right? And then we'll talk about it from the performance perspective, what we should do, right? And from the availability. So we'll touch base on these two, availability and performance. So we'll take up the availability first. How can we make sure our databases would be available in the cloud, right? That's the most important, availability along with performance, right? So everything with the cloud perspective. So we will understand that. Okay, so that's the agenda for today discussion. Okay, so first thing first, on-prem versus cloud. So if we understand the difference, what do we mean by on-prem and what do we mean by cloud, then only we can understand about the database. I hope most of us here are from performance testing engineering background. Yes, is that correct? You can just acknowledge yes, no, performance testing and engineering background, or DevOps professional and looking for SRE careers, right? So all belong to the same category. You can use the chat option to acknowledge, or you can unmute yourself. Is that understanding correct? Everybody here belongs to performance testing engineering background, most of us. Right, I see. Okay, Soumya is from functional testing. That's fine, Soumya, because we need to also understand the databases from a functional perspective as well. So the question still is relevant. Okay, so let's understand this first. On-prem versus cloud. What is the difference? So in on-prem and the cloud, see the data center, everybody understands the data center meaning. Data center is in infrastructure where we host, right? A lot of servers. Consider a multi-story building, right? Now, let me put that perspective. I'm going to give you an example. Let me start from beginning so that everybody are on the same page. Data center. What do we mean by data center? I'm gonna just show you a few images so that it becomes easy to understand. So consider a multi-story building in the outskirt of a city, multi-story building, multiple acres of land. Yes. Okay. Consider a multi-story building in the outskirts of a city, right? And somebody has to procure the land and construct the infrastructure, and then consider all the halls, all the rooms, big, full of servers, right? So this is a data center, right? Every company, be it Amazon, Google, Facebook, right, WhatsApp, they all have this data centers. Now, when we say on-prem and cloud, the question is who owns it? Whether you own it, if the company owns it, let's say you work in a company and the company owns such a data center, means you are working on-prem. But let's say if a company doesn't own such data center and they're leveraging some cloud service providers like AWS or Azure, so that's the cloud setup. So it is, as if we have to define simply, we can just say the infrastructure that we don't own will leverage. It is like how we stay in rented apartment. As long as we pay the rent, we can live in the rented apartment. The moment we stop paying the rent, we would not be allowed to stay, right? It is as same as cloud. If we want to use the servers, we have to pay some rent because the servers would host our applications, our storage, right? So when I say storage, consider like Netflix. Netflix use AWS, okay, and they use petabytes of data because they have so much of content, right? All the movies, serials that you watch, they are hosted in the cloud. They don't have their own data center. They use AWS. So they use the servers for the storage and they pay rent, right? So that's the cloud. But if let's say Netflix constructs this kind of data center, which is a very costly thing to build a data center, it's billions of dollars investment. Okay. So you need capital, a lot of capital, multiple billions of dollars goes in because you have to procure land, you have to purchase all this. Then there's a cost for maintenance, cooling mechanism, because these servers will generate a lot of heat. You need personnel for the maintenance because servers may run out of some issues, right? So we have a lot of cost factors. So that's why we rely on the cloud. So we don't have to worry about all these things and we can directly leverage it and we can pay some monthly rent bill and we can use the servers. That's the cloud. Okay. So are we clear with on-prem and cloud difference? A thumbs up, yes. And please acknowledge. Are we good? On-prem versus cloud, what do we mean? Okay, good. So now coming to the database options. So we have got multiple options in the databases, right? Either we can, for the databases, we have three options. We can install the database in on-prem, like we have our own server, our own data center. So in one of the servers, we can install the database in our own servers. So in on-prem, we can do that. Think about all the work that is required in on-prem. In on-prem, you need a DBA. So first of all, you need to do virtualization, right? Because since you have your own server, you will do virtualization, you will create VMs, and then you will install the database. You will have to maintain a lot of things. So what are the activities involved? So let's say when you work in on-prem, this is what you need to supposed to work. Okay, I'm going to put that here. Like, look at this. When you install the database in on-prem, because you own those things, so you have to take care of everything. You need to take care of server maintenance, OS installation, OS patches, power, HVAC, we call it cooling mechanism, and like all those mechanism, internet, rack and stack you have to maintain. And then you have to install database patches and you have to take database backups, right? Because we cannot lose the data and we have to keep taking the database backups. We have to take care of availability because I cannot have a single point of failure. One database, if I have only one database, if that goes down, I will have a downtime, right? I cannot afford to do that. So I have to take care of high availability. So everything scaling up and app optimization like SQL tuning and indexing, those things comes under app optimization. So when I install the database in on-prem, I have to take care of so many stuff, which is a lot. Okay. What is the second option? Second option is that I can get the server from the cloud. So this is on-prem, and I have cloud database, cloud installation. So I can use I can use cloud, I can get some server. So I don't have to maintain the rack and stack and HVAC. So I need not worry about server maintenance, rack and stack, OS installation, right? I don't need to worry about all these things. If I get the server in the cloud to install database. So that's the second option. And if you want the server in the cloud, let's say AWS, what is the service that we go for? Anybody? This is the cloud console, right? I'm showing you AWS. If you need the server in cloud, what is the service you would go to get the server? Is everybody new to the cloud?
AWS services, sir.
AWS services, that's correct. But in AWS, which service? To get the server.
EC2.
Yes.
S3 bucket we need to order.
S3 bucket is for storage, right? Somebody just mentioned EC2. Who mentioned?
Myself, sir. Soumya.
Soumya. So this is the AWS console, right? So if we want to use cloud, let's say Netflix wants to use cloud. So, or anybody, not just Netflix, a lot of people use AWS. Your Hotstar uses AWS, Amazon Prime Videos, Dropbox. There are a lot of NASDAQ, NASA. There are so many customers, they use AWS. So what we need, if you need the server, we have a service called EC2. We call it Elastic Compute Cloud. EC2 stands for Elastic Compute Cloud. So I will log into this management console and I will get some servers. There's a process. I can go to EC2 and I can get server. I hope everybody knows about it. This is a kind of a very fundamental thing in the cloud. If you don't know, that's fine. You need to learn cloud, okay? So we can go here, launch instance, and we can get some server, and we can specify some 2-core. Let's say if I want to get the server, so I can go to EC2, I can launch instance, and I can give the server name. I can select the operating system of my choice, Ubuntu, Red Hat, Windows, or whatever. I can select, and I can mention how much core and RAM I need, which we call it instance type. So usually for databases, we need more memory, more RAM. So usually we go with 8 core and 64 GB RAM, right? Usually for the database, we select at least four core. If not 4 core, 8 core definitely we require. And 32 GB is maybe good for most of the cases, but if you need more data, because we store more data, right? So we need more RAM. So 8 vCPUs and 64 GB RAM is mostly preferred. We preferred that kind of configuration. So we have that option. In the cloud, we have got multiple options here. As you can see, these are the machine types. So I can select some machine type here and I can get some server, and then I can log into this server and I can install the databases, right? So that's the second option. Get the server in the cloud DB installation. So get the server in the cloud and install the database. So when I do that, I can get rid of these many steps, because these many steps will be taken care by AWS. See, that is the region people go for cloud, right? One of the regions, because it's yes, obviously the setting up data center is very costly, no doubt about it. Not everybody can set up a data center. It's a multiple billion of dollars investment. But when you use AWS would have some role, right? Because they will take care of all these things. You don't have to worry about power and cooling mechanism, right? On and internet and rack and stack, server maintenance, OS installations. You don't need to worry about this. You can rely for these activities, you can rely on AWS. They would take care, right? And as a DBA, I would be focused on these activities. When you go for EC2 installation, server installation of the databases, I need to worry about OS patches, database install, obviously, because nobody would tell, right, which database I want. I may require RDS, relational database, or NoSQL database. In NoSQL, we have got so many options, right? So that we have to decide. Then we have to take care of high availability, backups, and scaling up and app optimization. That we have to worry. That we need to take care. But at least these activities will be taken care by cloud, right? So this is the second option. Still more work, right? The guy was crying here, as you can see, because this guy was having a lot of activity to be done in on-prem. The moment we move to cloud, at least this guy is smiling, and because these activities will be taken care by AWS. Now, we have got third options in cloud, right? So most of you, I believe, most of you would have worked on uh, these things, right? Somebody. So what database experience you have, guys? I would like to know. Before going to the third part, I would like to know what database exposure you have in your company. What type of database you're doing?
MySQL.
MySQL?
MySQL.
Okay.
Yes,
And
sir.
what are the options? First or second one?
It is second one.
Second one. Okay. So you are getting the server and you're installing MySQL on your own, right? Okay.
Yes, sir.
Perfect. How about others? So MySQL
So
belongs
in
to
my company,
yeah, go ahead.
we use Oracle 19C.
Okay, Oracle 19C. So again, the second option.
Cloud we don't have yet.
Okay, so in on-prem only. So,
Yeah.
so when you say, so you have your own server and then you install 19C.
Yes, yes.
Okay, okay. So that first option belongs to the first option. You take care of everything. Your company takes care of every activities, right?
Yes.
Perfect. Two answers. How about others? Just I'm asking of your experience, guys. What are you working on? So that you can understand which bucket you are. I'm going to come with the third option as well. We have the fourth option also. I'll explain two more options. Before that, I just want
SQL with cloud.
Okay, it's a SQL Server, Microsoft SQL Server, you're saying?
Yes. Mhm.
Okay, great. So you must be in Azure Cloud or in AWS?
Azure.
Okay, Azure. Okay, I was just guessing it. Okay, good. Good. So again, so two people here, one people in the first option. Okay. Okay, let me talk about third option. Maybe somebody would come here. So in third option, we have in the cloud itself, we have got managed services. In cloud itself, right? So if I go to AWS, cloud database managed services, what is this? And how different it is from this, right? So in this second option, we are only getting the server from the cloud. We are only asking server from the cloud, right? And other things we are taking care, the installation and OS patches, the high availability, scaling up, app optimization, that we are taking care. We are only getting the server from the cloud. In the third option, a lot of activities will be done by cloud because it's a managed service. It's a managed service, and cloud guarantees lot of availability, 99.99% availability, and they take care of a lot of activities. I will show you first what all the activities cloud take care and what are the activities we need to take care, the customer we need to take care in the managed services, and why these are popular. Okay, coming to the third option. This is the third option. I must have given you a surprise, most of you. A lot of activities is taken care by cloud, except one, app optimization. The SQL tuning part, the indexing part, whatever it requires, sorting part, right? Except those things, whatever requires for the performance. And it depends on use case by use case. There cannot be a fixed way to performance tune that, because it depends on your data, it depends on your business, it all depends on a lot of activities. So I'm just keeping it app optimization for SQL tuning, indexing, sorting, those activities, okay? Except those, every other activity, whatever you could think of, cloud would manage that. Cloud will take care of that. If you use managed services, and these services are trendy because companies do not have any dependency on people, right? They can simply rely on cloud. Yes, they need people for app optimization, so they can ask developers itself, because developers write the query, right? When they write the application code, they write the query. Or performance engineers, they can understand the slow queries and they can do write SQL tuning, they can improve the performance they can write better SQL queries, or they can do indexing, sorting could be done. So either developers or performance engineers can take up this activity. And apart from this, all the other activities, installations, first of all, DB installation. So DB installation is no more a task. When we go with managed services, your high availability is not a task now. It's just click of an option. I will show you. Click of option. Backup, taking a backup is just one option, that how frequently you want the backup. Everything is automated in the cloud using managed services. Surprised? Or at least amazed? I'm going to show you. So in the cloud, so this is EC2, that was the server. Now I'll go to the services section. Every cloud has it, okay? It's not a surprise that it's there only today. It's there for multiple years, okay? If you go to the database, all these are managed services in AWS. Similarly, like AWS, in Azure, we have managed services. In GCP, we have managed services. I'm talking about AWS specific here. All the services that you see here, RDS is relational, right? Your MySQL, your Postgre, your SQL Server, your Oracle, right? Your MariaDB, all those servers, all those databases comes under relational databases. This is also a managed service. And then we have NoSQL databases like DynamoDB. In DynamoDB, we store values as a key value pair. We have DocumentDB, which is like a Mongo database. We store all the records as JSON objects, JSON files, right? DocumentDB. And we have other kinds of databases. We have key spaces, like how we have for Cassandra, wide column databases. So we have key spaces. MemoryDB for Redis, like it's an in-memory database for caching. All the database options, we have got multiple database options. We have TimeStream, we have QLDB, we have Neptune, right? Elastic Cache, right? We have all the options here for different use case. I'll talk about the use case when we use what databases. All these databases comes under managed service. In the managed service, as I told, most of the activity will be taken care by the cloud. Okay, I'll give you a demo. I'll go to RDS. RDS stands for relational databases, relational database services. In RDS, okay, I hope everybody understands relational and non-relational. Do we understand? Yes, no? One quick acknowledgement will help. If not, I'll explain something.
No, sir.
Huh?
No.
Okay.
No, sir.
Okay. I got it. Okay. Let me just give you. I'll come to RDS part. Let me give you few things quick. Okay. Let me open one Excel sheet first. Okay. So, okay, you must be knowing relational, right? Because you're working on MySQL. What is the significant thing about MySQL or relational databases? the schema. The schemas are fixed. When you insert a record, we insert in a proper syntax, right? The schema is fixed. For example, let's say if you have an employee table or any table, right? You have columns, right? Could be name, could be age, right? Could be location, could be department, right? Could be salary, right? Role, whatever. Let's say I'm going to just give you some column name. So when we store values, see in database, what do? We store records, right? Basically, database is that. Earlier, when there was no database, we were working in, if you go 20 years back, we were working in a notebook. If you go to bank, let's say if you do, you must be going RD, right? Account, right? So if you go 20 years back, they were maintaining a register, a notebook, physical register, and they will open your name and they will mention, okay, deposit on this date, this much amount. Okay, withdrawal on this much date, this much amount. And they maintain this earlier, those 20 years back when they were not computer technology. Then we came to Excel. Then again, the data size grow. It was not manageable in Excel. Then we went ahead with databases, right? So it's all about how we store records, right? That's database. In relational, we have a fixed schema. Means if we have to store some records, we will store in the same way, right? We will put all the values. Let's say if name Ram is there, age would be some age, right? Location, like I can just mention some location, department, right? Development, right? Salary could be some 50,000 USD salary, and role Java developer. So I need to fill all the records, all the values. If I don't know, I'll mention null for something. But when I'm inserting records, I cannot skip anything. Yes or no? This is called relational, RDS. Relational databases. Now in NoSQL, what we do, there is no fixed pattern, because nowadays the data that we handle is non-relational. There is no fixed pattern. I'll give you one example. Everybody has mobile, right? Now tell me, when you add a contact in the mobile, right now also you can see, when you add a contact, how many fields you see to store a contact? Multiple fields are there. Yes.
Yes.
Yes. Is it a guarantee? Is it a fixed thing? Is it a mandatory to fill all the fields?
No.
Is it mandatory to fill only few fields?
Yes.
Mandatory means I'm telling about fixed fields. Is it a mandatory to fix? We have to fill those fields.
No.
There is no guarantee, right? What I'm
Yes.
trying to tell you, mostly we end up storing first name and mobile number, right? Mostly. Normal behavior, I'm saying. Normal, most of the users, we do that. First name and mobile number. Many people would also store first name, last name, mobile number, contact number. Few people may store some other details like email address, company. So the way we store records, is it a fixed thing? Tell me. You can try a few things. It will accept. It doesn't. There is no fixed thing as such. I can add email address. I can use company also. Mobile number also. I can leave mobile. It will not ask for any problem. Correct? Do we agree that there is no fixed way to store a value? Do you all agree on this part?
Yes, sir.
This is a NoSQL. It's a non-relational databases. There is no fixed pattern. Try inserting this in SQL. Try inserting a record. Try not to give a value. It will not accept. Have you noticed that? the fields are mandatory to be filled in relational databases. Try insert command today or anywhere, right? The fields are mandatory. If you don't know, make it null, but you have to value. Here, there is no guarantee. I can store as now. We cannot put a table as such. We cannot store in a table as such. So we have, let's say if I use MongoDB, I may use some sort of JSON file to store records, or I can use key value pair to store records. So that's the difference between relational and NoSQL, non-relational. There is no fixed schema in non-relational. No fixed schema. In schema is fixed only in the relational. So it's the way, because the data nowadays that we are handling, right? It is quite different. Look at this. I'll give you one example. All the items in the Flipkart or any retail application that you see, different item will have different specifications. Yes or no? Will one table would suit for all the items? Tell me. If I am purchasing a jewelry, my specification would be different. If I'm purchasing a car or a mobile, my specification will be different. Yes or no? Do I have the same kind of table? Can I get the records from the same table? Does my column, I'll simplify your question. Does my column would be same for jewelry and mobile?
No, sir.
Do we agree on this part, everybody? The way we are storing the records, there is a need that we cannot use always relational. We have to use non-relational databases as such, because we need to manage those records as well, right? Because here all the columns are same, all the records are the same, because here I'm maintaining employee list. Every employee list will have this detail. It's the fixed detail. Yeah, the values will be different, obviously. I have different employees, but this is the column would fit for all, right? Similarly, for mobile, one type of information would be relevant. Again, depends on mobile to mobile. iPhone would be having some different categories, some other category. So the way we're storing the records, the way we're storing the items are different. That's why there is a need for non-relational databases. You might have heard of, I'll give you one more example. Performance engineers or anybody, right? We see metrics, monitoring, right? Everybody sees CPU, memory, CPU response time, memory, throughput. We always see that, right? Yes. When we do performance test, or when we understand, when we want to understand how the performance is going on, we see these metrics. To store those records, right? We use different kind of databases. Do we know that? You might have heard of InfluxDB or Prometheus database, right? We use those kind of databases. What is the specialty of these DBs? We call it time stream database, time series database, right? These are time series database. They're optimized because the way we are the way we are storing the value here, what we have, x-axis we have time, and y-axis we have values. We don't have more columns like this in this kind of databases. So the requirements are different, is what I'm trying to tell. The requirements are different. For each specific use case, my requirements are different. So when we store the time series databases, the time series information, we mostly have x-axis. We maintain the time we have in x-axis, and in y-axis we have the values. For every 2 seconds or every 3 seconds or every 10 seconds, we will have a timestamp here, and we will have corresponding values. CPU, memory, right? Free memory, available memory. We will have all sorts of details. So the way we store those information in these databases are different, because these databases are optimized to store those kind of records. So for each use case, we use different databases. That's why we have these many database options. One, I cannot use always RDS or MySQL for every kind of use case. No, the performance will suffer. We cannot do that. That's why we have so many database options, right? I'll give you the one of the examples. Look at this. In AWS, we have these many options. We have relational databases, key value databases, in-memory database, document database, wide column database, graph database, time series database, ledger database. So depending on my use case, time series. Why will I use time series? Internet of Things, DevOps. DevOps, when I say, I'm talking about monitoring part here. Industrial telemetry. So we use for different kind of use case, we use different kind of databases. And AWS, this screenshot is taken from AWS documentation. And this screenshot is saying for every use case, AWS has a database. For relational database, we have RDS, which I was showing you sometime back. I'll show you in detail. For key value database, if you want to store as a key value pair, key and value, right? Let's say you want to store something as a key value. Key value means like this kind of information. There will be some key like name, age, right? Location, like you have key and a value. If you have such a requirement to store value like this, right? I can use this kind of deep. Right? So it depends on the use case, what database I require, what type of information I'm storing, what is the use case, business use case. So depending on that, I need to take a understanding of the use case, and then your architect in the company selects a database, right? Optimized for that requirement, right? Okay. So now we have got these many options. Now, coming back to RDS, the managed database, right? I was explaining you managed database. So far, so good. Are we on the same page? Hello? Are we good?
Yes.
Yes.
Perfect. Okay. Now, coming to relational the managed database. I told you when you use managed database, a lot of work will be done by AWS, right? Remember, I showed you that graph. Let me show you again. This slide. A lot of activities, all the red blocks will be taken care by AWS. I'm going to show you. I'm going to demonstrate using RDS. All the list that I showed you, all are managed database. I'm showing you one of the options in RDS. Now, I'm going to RDS here, and I'm going to create a database. I told you installation will be taken care by AWS. We don't need to worry about installation. So Soumya, you're working on MySQL and others working on SQL Server. Somebody DBA would have installed. And I'm going to show you something where installation will be taken care by cloud. Nobody has to worry here. So all you need to do is select the option. In RDS, we have got these many options. You can select Aurora, which is AWS database. Aurora has two options, MySQL and Postgre. They have improved the performance because Aurora is from AWS. You can select MySQL, you can select MariaDB, Postgre, Oracle, SQL Server, or IBM DB2. We have got these many options in RDS. I can select anyone, let's say MySQL or SQL Server. Anybody I can select. I will talk about I will just select the options, okay? I will not install. I will just select the option and I will click on create database. It will install things for me. I will select the version, whatever version I need. I can also select Oracle here, okay? Oracle also, I can select, and all I need to select the version. This is the 19 version. Okay, I'm going to show with MySQL. I can select one version. Okay, let's say I selected the latest version, right? Now, do I need to select for production development, testing, or free tier. Let's say I want to go for production because I will get many more options. I will get all the options for production. Let me show you all the options. You have a concept of multi-AG. Do we understand availability zone? In AWS, there's a concept of availability zone. Do we understand that? Himanshu understand. Others? Do we understand availability zone concept? Okay. Soumya, you need to learn cloud, okay, Soumya? It's gonna be very important for you,
Okay, sir.
right? So because they are very fundamental and cloud is gonna be the. See, okay. I'll take a few moments. See, every region, okay. I am selected Mumbai region here. Okay. In every region, we have got data center. So just consider availability zone as a data center. Usually, I have got multiple regions here. Okay, Mumbai. In India, I have got two regions, Mumbai and Hyderabad. Then I have let me show you AWS global infrastructure. Okay, if you look at the global infrastructure of AWS, where all AWS are present, all the green dots, right? This is where all the AWS are present. Okay, in India they are available in Mumbai and Hyderabad. Okay, similarly in Australia we have Sydney and Melbourne. Again, in Europe we have Spain. Lot of regions. Okay, so totally we have got 33 regions. AWS are present. When I say AWS present, they are data centers, and each region
Okay.
usually have got multiple availability zones. As you can read here, right? Mumbai has got 3 availability zones, means 3 data centers. And Hyderabad has also got 3 availability zones. Why we have multiple availability zones? For HA, for high availability. I would like to deploy my servers in multiple AZs in a region for high availability. If let's say if one of the AZs goes down, let's say for anything earthquake happened or natural calamity happened, and let's say one of the AZs are down, like flooded, right? One of these are not working. From a customer perspective, from a client perspective, would they want downtime? Think about it. Nobody likes to have downtime, right? So how can we avoid that? By deploying your servers in multiple AZs or multiple regions. Because if multiple AZs is absolutely required, because one AZ can go into issues. Could be natural calamity, earthquake, flood, could happen, right? Nobody's can guarantee. So we need to be available. So our servers needs to be available, needs to be deployed in multiple AZs in a region, right? That's why for high availability is required. So that's why that option was there. Okay. So they're asking, all there is asking, do you need multi-AG DB cluster? Do you want your cluster in multiple AZs? Obviously, for high availability, I will select yes. Yes or no? For HA, I will definitely select yes. Yes or no? And if I don't want HA, I will select single DB instance. So tell me one thing. From a deployment perspective, from availability perspective, which one I will select? First option or last option?
First option.
First option, right? Because I want to be highly available, right? So by clicking this option, AWS will deploy my server in multiple AZs, my database in multiple AZs. I don't need to worry about it. That's it, done. I can give a database name, the username, credentials, because I need to log in also, right? I need to insert some records. I need to do some tuning, right? So I need some credentials, right? Some encryption. I can select now. I need to mention, right? What's the server? What's the core? How much core? How much RAM? I can select from here, right? I'm just selecting it here, like how we select EC2. Similarly, I'm just selecting here. I'm not installing here, right? I am just telling, okay, use 8 core 32 GB RAM, or use, if I go for memory optimized, I will get 8 core 64 GB RAM, or 4 core 32 GB RAM. I will select this. It's mostly 4 core 32 GB RAM or 8 core 64 GB RAM is mostly we use it. Okay. Memory optimized, mostly the databases are. Let's say I selected one of the things. I can give storage also, how much storage I want. You might have seen the issue, like whatever the data disk that you're giving is running out of disk, right? Space is running out of space, right? In on-prem. In cloud, we don't need to worry about it. It's all about storage auto scaling. Do you want storage auto scaling or not? For the first option, it's not required, so it's not there. I will select the second option, multi-AG. I will select this. I will show you. This for the first option is not required. For second option, I'll explain you the difference. There's a difference, okay? Multi-AG, this also and this also, but there is an option. There is a difference of read replicas. I'll come to that. Read replica later, okay? But there's a difference. I'll select the second option, and I will show you that there is an option of auto scaling. All I need is to check this option and give the maximum value. It will start with whatever I have given here. But if it requires, if it's running out of space, it will auto scale in managed database. If I go ahead with managed database, is this cool, guys? I hope many of you would not have seen this feature. Do you think it's cool? Nice feature?
Yes.
Right?
Yes, sir.
Now, I can connect to an EC2 instance. I have this option also. I can select my VPC, which network I want to deploy this. Do I need public access or not for the database? I can select this. I can select all the options, and at the end, what I will click? Create database. It will take some amount, definitely, because I have selected a highly configured machine, 8-core machine. That's it. It will create data. It will take 10 minutes and it will give me a database. I will not click on create because I have selected a highly configured machine. I don't require that much high configured. I was just showing you all the options. Create database. I can create a database here. I will just click on this. It will install database. I will get a database instance with multi-AZ availability, with auto scaling enabled. Storage will be also, I can, once my database is created, I can select the option or also option of how much, what frequency of backup I need. I can do that. So this is only possible in the third option. Okay, I will show you this database sometime in the course, right? I have, I go over in detail. Okay, right now we are working for this workshop. I'm just giving you kind of a overview, high level overview, but it's good enough to understand. Okay. Okay. So this is the third option. Okay. Did we understand this third option? I'll come to this read replica part. What is the difference between these two? I'll come to that part. Are we good with this third option? I hope we understood the third option.
Yes,
Yeah.
sir.
Third option. And we have got multiple databases. Okay. Not just one. Okay. I was showing you. All are managed database. Depending on my use case, I can select RDS, I can select relational, I can select non-relational, no SQL. It all depends on my use case. Do I need key value pair? I can select DynamoDB. Do I need wide column? I can select key spaces, which works like Cassandra. Even Facebook has Cassandra. Do I need time series? I can use time stream. In third party, we have Influx Prometheus, like same as time stream. Time stream is for AWS. Do I need document database? I can select document DB, which is like a MongoDB compatibility. I have all the options. For every use case, I have an option in AWS. No. how high availability works, right? So these options which I was showing you, right? If you read these two options, the difference lies in high availability and read replicas. Two things. If you read this, right? Read this. First option creates a DB cluster with primary DB, means first primary database instance, and two readable standby. What is this two readable? Okay, I'll come to that. With each DB instance in different availability zone for high availability, right? Obviously, whenever they talk about different availability zone, they're talking about high availability, which provides high availability, redundancy, and increases capacity to serve read workloads, right? So there's a concept of read replicas. I'll talk about that to improve the performance. And this is the normal, guys. Here you don't get read replicas. Here you get two readable standby database, right? You don't get this. In multi-AZ, you simply get two databases, one in primary, one we call it secondary, in another AZ or region. So there's a two options, how to achieve high availability and how to achieve better performance. This talks about high availability, okay? So it's for us, it's about just clicking that option, okay? And high HA will be taken care. But this is how it is being done. So you have a primary database in one of the AZs. If this database goes down for any region, right? The traffic will be routed to this database, which is in another AZ. And now the problem will happen, right? If I don't have the same data, right? Because all of a sudden I cannot switch the traffic to this database. If I don't have the data, then it will be a problem, right? So that is why what we do here, synchronous replication. So synchronous replication makes sure that I have the same data present in both the databases. This is done automatically. If you do this manually, if you select first two options, HA will be taken care by you, DB. You have to take care of this. Most of the companies, they do not do HA because of the complexity. Lot of technical things involved, right? Most of the companies. Now, I'm not saying all the companies, they do. In on-prem also, you can do HA. This is the way to do HA. You need to maintain two databases. The traffic will be routed to the primary one, and the data will be synchronous replicated to other databases. Once this database failed, automatically, there has to be one guy which can sense that, okay, this database is down, this AZ is down, switch the traffic to another AZ. It will be done. So this is how high HA is being done. Now it's up to you. You do it in first two options, or you rely on the cloud to do in the third option using managed services. Are we good with HA? How do we achieve HA? Yes, no? Any questions?
Yes, you are good.
Good? Perfect. Now, second option. What if there are a lot of traffic coming in primary database, what would you do? Okay. What do we do in database, guys? I want to ask a fundamental question. Either you read data or you write data. Yes or no? Do you do any more activity?
Yeah, not usually.
Right? Either you read data using select queries, or you write data. These are the two activities being done. When I say write queries, write data, I'm talking about update, talking about insert, I'm talking about delete. Mostly we do these activities in a database. So the traffic comes, this is what we call it I/O, right? Input, output. You might have heard this term, I/O. This is what we mean I/O, input, output. Either you read data or you write data. Now, my question is, what will you do if there are a lot of reads happening, let's say reads happening and write happening to the primary database? What would you do? And your performance is getting choked. Can this happen over the time? Yes or no? Can this happen? Yes. What would you do? Route it to backup server. Come again? No, the backup server is the same configuration, right? This also the same configuration. So in parallel, we can route the traffic to both the servers. Okay, you can route the traffic to both the servers, understand. But again, you need to take care of HA then again, right? Let's say one server goes down, the entire data would be replicated. That I understand. Both are single replicated, that's good. But again, you need to take care of HA also. Both the servers is good. One of the options, yes. So basically, you are telling, create one more server and route the traffic, correct? And distribute the load. Yes, right. But understand one thing. There is always a primary database where what we can do, I'll tell you the second option. Can we split the write and read? Tell me. Can that help? I can write to only one database. Because when I am switching the traffic, I'm increasing the replication among these two. This because update can happen here, it will replicate here. Update can happen here, it will replicate here. That is also a problem, right? That is also a load. Why not? I can separate read and write. Let's say for heavy read activities, can I create one more instance? And I can switch the reading. I can get the reading from that database and only the write to this database. Can that solve a problem?
Yeah, might be. We can use in-memory database also for that purpose.
Yeah, in your database will work, but again, the cost will also increase, right? Because you need to store everything in the RAM. So caching will cost. Caching will have a cost part also. We'll come to that caching part. But think about this. Let's not talk about caching as of now. What would you do? Load has increased. Read and write has increased to the prime database. We have got two options. Scale up this. Let's say from 8 core, I can go to 16 core. 16 core, I can go to 32 core. That's one option. So that more read and write can happen to the same database. Second option, I can find the read queries. Why the reads are happening? What is the region? And I can create one read replica. The concept is read replica. So I can create a read replica, which will be the same as your primary database. From the primary DB, I can create a read replicas. This is what they were talking about in this. Two readable standby DB instances. They are talking about read replicas only. So the first option will create read replicas also and high availability also. If you just check this, right? If you just click this, yes, the amount will be more, but they will create standby database also, and they will create two read replicas also. With just click of an option. If you just select single DB, you'll get only one database. If you select this option, you'll get all those things. So when I say read replicas, I'm talking about this. So I will create a read replicas and I can route only let's say I am using few reads for reporting. For reporting, why do I need to hit this primary database, right? I don't need to. So I can create a read replicas and I can get some reporting done using these read replicas. So that will reduce the load on my primary DB. Yes or no? I'm not saying completely remove read. No. You need to select where the reads are coming from. A lot of reads. And you can only redirect those requests, the primary, the major chunk, to the read replicas. So this will release the pressure, a lot of requests from the primary DB, right? So HA, we use that concept, and read replicas for the performance. We do that, okay? So remember these two options. We take care. Okay, so this is what we wanted to cover, guys, today in the workshop. And I hope everybody got the difference between these three. Are we good? I hope we learned something in this 1 hour.
Yes.
Great. So I'm just going to give you some information, guys, about my course. You can go over it and decide, okay? So tomorrow is what is the day one. Last week, we had a demo session. I'm going to talk about this course. I'm going to give you this link. And I have this course on the SRE, Cloud Performance Engineering and DevOps, we call it, right? And we talk about AWS here, we talk about Linux, we talk about Kubernetes, we talk about Docker, we talk about Jenkins, we talk about monitoring, Prometheus, Grafana. We talk about a lot of things in this course, okay? Go over this and join tomorrow for day one. I'll give you more detail about the course, okay? If tomorrow we'll discuss that, and then you can decide if it's going to add value addition to you or not. It's quite a big course and quite a useful course. Okay, I am running this course from last 3 years, and many people have got benefited. You should have a look at it. And tomorrow, will you connect? We'll discuss about this course. So today, I'm going to just give you this link, and you can go over it, and then you can meet tomorrow. I've saved the link in the chat, and we can meet tomorrow, and we'll talk about the course. Okay, we have a lot of things. In the observability, we talk about Prometheus, Grafana, Elk Stack. In troubleshooting, we talk about Java performance tuning. We talk about a lot of things, okay, in this course. So I'll give you more detail about the course tomorrow, okay? So I hope everybody got the link. So feel free to attend tomorrow's day one session. And we're going to continue, okay, with the course. So course has already started. If you need to decide, you decide quickly, and post tomorrow call, you can decide better. So tomorrow is what we're going to meet for the day one. Last weekend we have met for the demo session. I'm going to give you demo again tomorrow. Those who could not attend the last session, and we are starting. Okay, so tomorrow is going to be day one. Sounds good? So that's all, guys, from myself for today.
Thank you.
Thank you. Thank you so much.
Thank you so much, guys. If you have any questions on databases, feel free to ask me any question. Thank you so much.